In this video, I'm going to use JASP to conduct a single sample mean t-test to address this research question. Is the mean commute time in Atlanta, Georgia different from 30 minutes? I have a data set that contains data concerning the commutes of 500 residents of Atlanta, Georgia, which I'll use to address this research question. When we're using statistical software to conduct a hypothesis test, the steps will be slightly different because the software will compute the test statistic and the p-value for us. So there's no need to do any calculations by hand, and there's no need to use the critical value approach. I still like to start by writing the null and alternative hypotheses. Here, we want to know if the population mean is different from 30. Different from is equivalent to saying not equal to, which means that we'll be conducting a two-tailed test. Recall that the null hypothesis contains the possibility of inequality, and the hypotheses are always written in terms of population parameters. Our null hypothesis is mu equals 30, and our alternative hypothesis is mu does not equal 30. Now, let's use JASP to obtain our t-test statistic and our p-value. Under t-tests, select one sample t-test. The variable we're interested in is time. Double-click time to move it over to the variables box. The default test is student, which is the student's t-test. That's a more formal term for the procedure we learned this week. The default test value is 0. This is equivalent to having a null hypothesis of mu equals 0. We do need to update this to match our null hypothesis, which was mu equals 30. We have three options for the alternative hypothesis. We're conducting a two-tailed hypothesis, which is the default, but JASP also has options for a right-tailed test or a left-tailed test. Now that we have our test value and alternative hypothesis set up correctly, over on the right, we have our output. Our t-test statistic is negative 0.961. The sample size was 500, so the degrees of freedom are 499. And our p-value is 0.337. We can use this p-value to make a decision about our hypotheses. We'll use a standard 0.05 alpha level. Since the p-value is greater than the alpha level, we fail to reject the null hypothesis. There is not evidence that the mean commute time in the population of all of Atlanta is different from 30 minutes. To interpret this p-value, what we're saying is that if the population mean were 30, and we were to repeatedly pull random samples of 500 commute times, 33.7% of those random samples would have a sample mean equal to the one in our sample or more extreme. In other words, it would not be too unusual for a population with a mean of 30 to produce our observed sample. The output we have here is really the bare minimum output for a single sample mean t-test. There are some additional statistics available here as well. Location parameter gives us the mean difference. This is the difference between our observed sample mean and the hypothesized population mean of 30. Confidence interval will give us a 95% confidence interval for that difference. The default is always 95%, but you can change that here. Next, we have effect size. This will give us Cohen's d. That's the difference between the observed sample mean and the hypothesized population mean in standard deviation units. The confidence interval box here will give you the confidence interval for Cohen's d, which we are not going to be using in this course. And the last box that you might want to check in this course is descriptives, which gives you the basic descriptive statistics, including sample size, mean, standard deviation, and standard error.